Hello guys, my name is Juan Leal. Today we're going to be working on this problem. Okay, my topic was implicit differentiation. So we're going to be doing that, applying that principle to this problem. So the equation we have with us today is x y cubed plus xy is equal to 10. The coordinates we got was for the x value we got 5 and for the y we got 1. And the two variables we want to find is m and b. Okay, so the first step in any implicit differentiation problem you want to do is derive everything. That is one of the biggest qualities of this principle, because even both the x and the y's have to be derived with respect to x. So we did that right here, and we used the product rule twice in order to get that down to a complete factored form. So we first off we derived dx, and dx over dx is equal to 1. So you can leave that as it is. And the product rules say that you don't derive the second variable. When we continue, we don't derive the first, but we do derive the second one, leaving us with 3x squared dy dx. This dy dx is very important for you guys to remember. This will be the variable we will equal everything to at the end, because this, as we all know, is the derivative of y. And what is another word for derivative? Slope. Okay, so we continue with the procedure, and we find out that when we derive the x and the y, we get y plus x dy dx is equal to 0, because 10 is a constant, so derivative of any constant is 0. So now we can continue, we can pair up all the like terms. So I will do that now, and that will leave us with y cubed plus 3xy dy dx. Remember this dy dx, guys. This is very important. Plus y plus x dy dx is equal to, we just move that 0 down, 0. Okay, now that we have this, we can see that we have two lone variables that we can take out of the equation. So we can do that now. So we subtract y cubed and y from both sides, just like so, making these two cancel, and this 0 changed into that. So we will end up having 3xy squared dy dx plus x dy dx is equal to negative 3y minus y. Okay, now that we have this, we can see that in both of these factors we have a common dy dx. So what we do now is we factor this dy dx, and we can factor it out from both terms, as we said. So by doing that, we are left with 3x y squared plus x is equal to, and we can just simply move this down to negative y cubed minus y. Okay, we have this, right? So the thing we want to do is just isolate this dy dx. So, and how do we do that? The only way we could do that is by dividing both sides by this entire portion. So we divide it, right? 3xy squared plus x divided by 3xy squared plus x. These two cancel, leaving us with dy dx is equal to negative y cubed minus y all over 3xy squared plus x. You may be thinking, what is this? What does this dy dx represent? And as we had said from the beginning, dy dx is simply the first derivative of the y variable. What is a derivative? Again, as stated by Professor Banda, the derivative is just another word of slope. So now we need to solve both of these variables. So we set this equal to m, right? And as we know, m is another word for slope, and slope is also a synonym to derivative. So we take this dy dx and we put it to that. As we had calculated dy dx was equal to this equation, so we just run it down over here, which is negative y cubed minus y all over 3x y squared plus x. Now that we have this, we need to isolate the m. How do we do that? We do that by simply getting these two coordinates and plugging them in for the x and y values. So if we do this, we get for the numerator, the y will be 1 cubed minus 1 minus y, which is 1. So that will leave us set for the numerator. Now for the denominator, 3x, we were given that x was 5, so we plug that in, times y, which is 1, squared plus 5. Okay, After you do some simple calculations, we can calculate that this is the same as negative 2 over 10, which, over 2 over 20, sorry, which is, when you simplify, negative 1 over 10. So now we have our m value. So we can write it down over here. As so, negative 1 over 10. Okay, now that we have m, it is time to solve for b. Because we have all three x, m, and y values, we can take this formula again and just substitute the values we have from the original equation. So y we said was 1, m we calculated was negative 1 over 10, x is 5, and we're left with the variable b. Okay, we want b to be by itself, so we multiply these two, which will leave us with 0.5, negative 0.5, plus b. By isolating that, we just add 0.5 to both sides, canceling these two out, making b 1.5, which we can write up here, and that gives us our answer.